Everything is in motion. Everything flows, collects energy, or transmits it. But how can it be measured? How can it be monitored? What does it describe? And how can it be made visible? Its various sizes captured, quickly and easily, and completely reliably. Its characteristics correctly verified. Discover the new generation of test technology for energy supply. The Gen X test systems from MTE. Measurement Heroes by MTE.
Dear ladies and gentlemen, good morning and thank you very much for joining today's webinar about portable meter testing. Portable meter testing as an aid to increasing an energy supplier's overall customer service and satisfaction levels. Having been active in this field for decades, MTE understands the importance of portable meter testing and just introduced its new Gen X product line. With the support of ENLIT Asia, MTE Meter Test Equipment is very delighted to sponsor today's webinar, and we are very pleased to welcome our panelists, Mr. Ken Lim Teik from TNB Malaysia, Mr. William Chan from Meralco, the Philippines, and Dr. Chayo Pirak from TGGS in Bangkok, Thailand, as well as my colleague, Mr. Horst Adams from MTE. Horst has been our regional sales manager for Asia Pacific for more than 20 years and will now share with us some of the most common technical and non-technical challenges of on-site metering installations, followed by some practical examples and suggestions from MTE on how we address such tasks and challenges. Afterwards, we are very excited to listen to our panelists with their broad experience in their application fields in Malaysia, the Philippines, and Thailand. Later on, we will deepen our discussions and have also some time for additional queries during the Q&A session. Thank you once again for joining us today. And on behalf of MTE, I wish you a very interesting and entertaining webinar.
Thank you for the introduction, Luca. So topic of my presentation is the benefits of portable electricity meter testing. On-site testing has been common for more than 40 years. At the end of the 70s, the first wide-range portable reference meter with integrated error calculation was launched. It was called TVH4 from Landesingir, so where MTE's roots come from. Nowadays, we see 4 major applications for portable meter testing. First, consumer protection, which means utilities charge and treat fairly their customers. Secondly, customer complaints. With increased energy prices, quantity of customer complaints rises up as well. In former times, the utilities dismounted the meter and tested it in laboratory. Nowadays, they convince customers on site because credibility is higher. Particularly for smart meter rollouts, customer complaints and concerns go up. Experiences show that smart meter installations should be accompanied with a meter test before and after installation. Last but not least, reduction of non-technical losses is another reason. There are big issues in many countries. Portable test equipment is one of the tools to detect accidental and intentional mistakes. Coming now to consumer protection. As an example for consumer protection, please let me introduce the on-site testing in Sweden. Based on the Swedish law for field verifications, the on-site test must follow ISO 17020. Our experiences with the Swedish system come from our German partner EMH, Messtechnik, who provides such an accreditation service for several Swedish utilities for about 10 years now. The Swedish model classify the meter setups in 5 categories. It differentiates between direct and indirect measurement, with CT and PT connection. It is related to power measurement and also the accuracy class of the meter. It defines a total maximum allowed error, including CT, PTs, and the cabling. In metrology, the error for meters and instrument transformers are treated separately. But here, they have another approach and determine the total error for the complete setup. For instance, you can see here the category 5 with a power of more than 10 MVA, equipped with the class 0.2S meter. The total allowed error, including CT and PT and related burden, is plus minus 0.5%. So what sort of tests are required in Sweden? Compulsory test for all categories is a wiring check by vectorial diagram, usually achieved by using clamp-on CTs. Most of the problems are wrong connections, which results in big losses. In such a 4-quadrant diagram, it is easy to analyze phase sequence of voltages, phase sequence of currents, the total energy flow, and also interruptions or short circuits. Another important test is the meter accuracy test. Connection can be done by current clamps or also directly connected. Scanning head or pulse converter is used, and pulses of the device under test and the reference meter are compared. In Sweden, the load is defined between 20 and 100% of the maximum current. When this actual load is too low, portable phantom loads must be connected. You know, nowadays, portable electronic phantom loads are very small and low in weight. Therefore, they are easy to transport on site. They have to store 10 measurements, including calculated average value and standard deviation, which you can see here. For category 2 up to 5, the total error includes also the CTs and PTs, which has to be determined. For the categories 2 to 5, a burden test is mandatory. On CT's secondary side, voltage and current is measured, and the impedance is calculated, which you can see here. The operating burden must be in the range of 25 to 100% of the nominal burden. In this example, you see the operating burden is 70%, means it is in the limits. Such a test is important to detect accidental mistakes like corroded clamping points. But also intentional mistakes can be found, for instance, prolongation of the secondary current cable, which is one of the easiest methods to lower the energy measured of the whole CT metering setup. For category 3 to 5, a burden test of the PTs is necessary. Here, the admittance is determined, and the operating burden must be once again between 25 and 100% of the nominal burden SM. Summarized, depending on the category, totally 4 tests are required in Sweden. Wiring check for all categories, accuracy test, also for all categories, CT burden test for the category 2 to 5, and PT burden test for the categories 3 to 5. I mentioned earlier, our German partner EMH provides ISO 17020 conformed services for several Swedish utilities. This includes the annual calibration of the portable test equipment, maintenance and replacement of the test equipment, theoretical and practical training of the staff, and ISO-conformed test certificates, where you can see an example here on the right side. This photo shows, for instance, a setup with a portable electronic reference standard class 0.02, remote controlled by a display positioned in the van. Next reason for on-site meter tests is complaint handling. For instance, in Brazil, with the introduction of modern meters, usually the electricity costs increase as well. This leads to a lot of complaints, questioning the accuracy of the new meter. There is a resolution of the regulatory agency in Brazil called ANEL, which defines occurrences. It requires to visit the site and execute 3 measurements. 3 measurements for 10% and also 3 measurements for 100%. Next example for complaint handlings is the metropolitan city of Shanghai. Shanghai has more than 5 million installed smart meters. You know, smart meters are not 100% accepted. For clearing of customer complaints, they employed 25 inspection teams. Maximum time between customer complaint and visit on site is 7 days. These inspection teams check the accuracy at defined load points. In the first 6 years, each team handled around 1,000 cases, means in total 25,000 cases. In some countries, portable testing is part of the smart meter rollout. For instance, Saudi Arabia. Later on, we will get here another example from TNB, Malaysia. The procedure is as follows. Check the accuracy of the old meter before removal. Check the accuracy of the new smart meter after installation. Target is to convince customer and improve the trust in the new smart meter. For this job, SEC Saudi Arabia use around 500 portables. Non-technical losses is a global problem and accounts for billions of dollars in lost revenue. Portable meter testing can help to detect accidental and also intentional mistakes in metering. Such mistakes can be energy theft, for instance, measuring the current in neutral line and compare with lifeline, detection of meter tampering, or nowadays also hacking of meters, which might be also a new big problem, poor meter quality, like drifts, mistakes in meter and CT-PT connections, wrong CT ratios, and increased CT burden. Start. Analysis of the number of cases and financial losses show everywhere more or less the same results. When it comes to the cases, 80% of the cases are residential and 20% are commercial or industrial. A look to the losses shows that 80% of the losses are commercial. Here you see the orange part of the cake, and 20% of the losses are residential. This effect is called Pareto Principle, or 80-20 rule, which states that for many outcomes, roughly 80% of the consequences come from 20% of the causes. With other words, for our case, when a utility checks the commercial and industrial metering setups, they can address 80% of the financial losses. So which instruments are on the market? For instance, from MTE. This slide shows the actual portable MTE product range pyramid, starting with the high-end instrument in class 0.005 and 0.01 for testing other reference standards, then instruments in class 0.02 and 0.05 for industrial applications, down to handheld instruments in class 0.1 and 0.2 for testing household meters. They are available as standalone instruments, you can see here on the right side, or can come with integrated voltage and current sources in different accuracy classes. They cover all actual requirements for consumer protection, customer complaint handling, smart meter rollout, and detection of non-technical losses. Thank you for your attention, and I forward now to Simon. Simon, please.
Horst, thank you very much for that insight there, and thank you, Luca, for the introduction to this discussion. Ladies and gentlemen, my name is Simon Hall. I'm the content producer or content director for ENLIT Asia. Once again, I'm joined now with our speakers for this panel discussion. We've already heard from Horst. He is sales manager for Asia Pacific with MTE. I'm also delighted to be joined by engineer Lim Tek Ken, head of technical for DNB Distribution Division, Dr. Chayod Pirak, associate professor with the Sirindhorn International Thai German Graduate School of Engineering, and William Chan, manager for metering services asset management with Meralco. We're now entering into a bit of a panel discussion, and while this is recorded and we can't take live questions, we do have some representatives from some of the organizations on the chat today. So please, if you have a question, at any point, please type it into the question box on the right-hand side, and they'll take the time to respond to you. We'll get through as many of those questions as we can, and you may well hear from some of the speakers after the event as well. What I'd like to do now is briefly give maybe 3 or 4 minutes to each of our speakers to provide a brief overview about their company and about the portable test program within their organization. I'd like you guys to touch on topics such as the area that you're covered by your utility, the area that is covered by your utility, when your portable test program started, how many inspection teams you're using, and obviously we're living under this cloud of COVID. So any impact that you've seen due to the ongoing COVID situation. Perhaps, Ken, I could start with you.
Okay, thank you. All right. I think so. I'm Ken, and basically I come from Tenaga Nasional Berhad (TNB). We are the largest electricity utility in Malaysia. So we have about close to 10 million customers as of 2020, and what we are looking at, that constitutes about 117,000 gigawatt hours per year, right? So in regards to the portable test meter program that we have, for TNB, we started somewhere in the early 2000 actually, and the motivation, or rather the focus then, was actually to use this portable test sets to manage NTL. And currently we have a dedicated set of teams that do these inspections on site. They number around 140 teams right now, and what we do over here is that we have the whole current metering, right, and also the current transformer metering. These two categories, they have their respective inspection regimes. Of course, we would expect the the higher consumption customers, we have a defined schedule that we do every year, and the majority of the customers, which are the whole current meters, that is done on a sampling basis, and then and based on needs from time to time. So that's what it is right now. And I would also like to share that as we're moving towards digitalization and all that, TNB is also currently doing the smart meter rollout, and we've done so far 1.1 million, right, installations. And part of that exercise that we are doing in Malaysia right now, one of the main key requirements is for us to do inspection of the meter, the existing meter, before and after we have replaced it with a smart meter. So in essence, that summarizes the current situation that we are having in TNB right now. Okay.
Thank you. Thank you. Chayot, can I move on to you?
Okay. So, all right, thank you very much. So my name is Chayo Pirak. Actually, I'm the consultant to PEA, and I work as an associate professor in TTJS, King Mongkut University of Technology, North Bangkok. So let me briefly introduce the background of PEA to you. Actually, PEA provides a service to 73 provinces around the country of Thailand, excluding Bangkok and 3 vicinity provinces that are under responsibility of MEA. So concerning the sold energy per year, PEA sold about 134 gigawatt hour, that worth about 2,730 million US dollars. So the price per 1 kilowatt hour is about 5.15 cents, right, per unit. So concerning the portable test programs, actually PEA normally calibrate revenue meters of VSPP once every 2 years. At the moment, they increase the frequencies to be once a year, right, and mainly focus on the VSPP. And concerning the area that provide this provided service by PEA, they have about 12 regions, right, and each regions has about 4 inspection teams, and there are about 4 to 5 portable PWS 2.3 model, right, that has been used, and each team would be conducted by the head engineer for the inspections. So as you know, nowadays we have the COVID-19 pandemic, right? And inspection, right, to the revenue meter is not performed regularly because it's very difficult to enter to the site. So during the COVID-19 outbreak, PA stopped the inspection program for a while.
Mm-hmm. Mm-hmm. Yeah. William from Meralco.
Thank you, Simon. Hi, everyone. For the Manila Electric Company, it's a 118-year-old company and the largest in the Philippines as a distribution utility. We cover around 9,685 square kilometer in our franchise. That includes 36 cities, 75 municipalities, and the country's industrial, commercial, and population centers. We have around 7 million customers, more than 7 million customers. Meralco's journey to the portable meter testing started way back in 1936 as a compliance to some regulation to ensure accuracy of the meters. We were using then a kilowatt hour standard and a phantom load to test the on-site accuracy of the meters. It was in 2003 that when we first acquired our commercial portable meter test equipment. Today, Meralco has around 65 tools that ensures the integrity of the metering installations. 30 crews conducts the meter accuracy testing for single-phase and polyphase metering installations. They are divided based on the area of jurisdictions. It's north, central, and south of our franchise area. And we have around 32 portable test equipments today. Meter accuracy testing is usually done in response to our customer requests or sometimes complaints, and also as a request from other offices, usually the billing offices, when there are concerns in the reading or registration of the meter. Aside from the meter accuracy testing, we also have another procedure we call the phase angle test. It checks the integrity of the metering installations, usually for the city-rated meter. The key advantages or benefits of using these portable test equipments includes faster response to our customer complaints or requests, resulting to their satisfaction, compliance to our regulatory requirements, maintenance of the integrity of our metering installations, and reduction in our non-technical system loss. The COVID situation last year and this year resulted to reduction in our work orders for meter testing, around 40% reduction compared to 2019. There are additional requirements that the customer usually asks from us before we are allowed to conduct the test, and that includes, among others, presentation of medical certificates and also compliance to their safety protocols. Yeah.
Yeah, I mean, the COVID situation has certainly impacted everyone. Ken, you mentioned that TMB is in the middle of the smart meter rollout. We've had a few conversations with TMB about this, and it's progressing well. One of the bits of feedback that we get quite often around sort of new technologies generally, such as smart metering, is sort of the reservations about the use of these digital technologies. Is on-site metering, is on-site testing kind of supporting the acceptance of these new technologies, and how else are you supporting the smart meter rollout?
Okay, I think when based on our experience from the early 2000, when we used these test sets for NTL, right? It's always going to be centered around, I would sum it up as 3 key points, right? The first one is to give the assurance to the customer that the equipment, or rather the meter that they have on site, is actually performing as it should, because that ultimately translates into a bill, right? So that be the first key point, that key consideration when we're doing this program, right? The other thing is transparency, right? Letting the customer know exactly that with new technologies, right? There is always the reservation whether the utility is actually tweaking something at the back end to increase the bills, those kind of things. Yeah. It's very common, right? And for one reason or another, whenever a meter change seems to happen, it's always associated later on when there is an increase of bill of the monthly billing. They always attribute it to the change of the meter, when in reality, from our experience, we have seen, and we have actually gone through numerous exercises to show that more often than not, it's always there's always another real reason why the bill increases. But to be able to do that, we must be able to show to the customer that that the meter, it's okay before we change it, right? Mm-hmm. So insofar as AMI is concerned, we've now done 1.1 million. What's very interesting here to note is that TNB together with the regulator, it is a mandatory requirement for us to test it before and after. So that in itself tells us the current health of the meter. Now, if there is any discrepancy, the meter is running slower or faster than it should be, that is actually explained to the customer prior to the change itself, right? Okay. So that increases the confidence level, and therefore, should an increase in bill happen after that, right? Then we always will be able to fall back on to the initial inspection that we have done. So that essentially instills greater confidence in what we're doing, right? Anything new, electronics and all of that. And I think what's really helped us here is that we've had the experience of the NTL teams, right? The 140 to 150 teams that we're talking about, that we currently have. That's the usual day-to-day inspection. So now coupled with what we do for AMI, on an average, we have actually hit a peak installation meter change per day of about 6,000 meter change a day. That's carried out on a peak level of about 800 teams. So you can imagine you have these teams running on site. The volume it's really big, right? Yeah. Now without this portable test equipment, I don't think the rollout will be able to happen at such a scale. So definitely we're using this to give the assurance, and also hopefully to continue as we go on in this AMI journey for TNB and for Malaysia, right?
William, I could see you smiling and nodding in agreement to some of what Ken said there. Does that echo your own experiences? You mentioned some of the benefits you've had of using portable meter testing in your opening there. Is that similar to your own experiences in terms of helping to put minds at ease?
Yes, I was agreeing to what Mr. Ken said, because to the point that there are customers who really blames the meter whenever there's an increase in their consumption or bill. Usually they focus on the meter and says it is registering on the high side. So, well, that's why I really tend to sympathize with what he said. So,
in terms of the advantages that you mentioned in your opening, could you dig down a little bit deeper? What are your experiences in using portable meter testers, and what other advantages have you seen?
Well, for the experiences in our portable meter test equipment, there were some challenges that we experienced, mostly related to the failures. This equipment is usually brought outdoors and is subjected to the rough field conditions, such as rain, heat, vibrations, and so on. We also have some cases where that we were able to track to seepage in rainwater, fine dust particles, and that were inside the devices and contaminates the switches and test leads. Other also defects are loose connections, defective toggle switches, and current clamps. Now, we also have some challenges when we are incompatibility issues now. Our portable test equipment usually when the portable test equipment is only for a specific kind of meter. For example, there are incompatibility issues on the design. For example, when the test equipment is only for ANSI meter or ISC meter, there are also issues that we experience for the connectors. Sometimes we have round connectors, and the others are with use some clips or what. And also there are also some incompatibility in mounting sockets, different head sensors for those that require for those types of meters. You know, we have some meters have infrared and the others are visible light. And also we have some mismatch maximum equipment rating with the meter that is being tested. So those are some challenges that we have encountered in the use of our portable meter test equipments. But I guess most of the modern equipments now can address this easily.
Yeah, and Chaya, you were also smiling knowingly when Ken was talking about some of the issues that they faced on the technical side in terms of acceptance, etc. I was interested. Can you talk us through the purpose of on-site testing time? Why was it decided that this would be the route to follow?
Okay. So, let me briefly introduce the project in Thailand to you. For actually PA now, they launched the pilot project in Pattaya area, which is the tourist attraction. So it's about 116,000 AMI meters. So, and we found an interesting case. So I agree with William and Ken that there's some complaint from the consumer, right, who used the electromechanical meter before. So they got higher bill, right, because maybe, you know, the electromechanical meter at the time, the accuracy is not that good, right, and it's measured below the what they could be. So they also complained. Then PA had to send the staff, right, to show they exactly used that amount of energy. So they got the correct bill. So at the first time, they used like the clamp-on meters, they used whatever things. But I think the very effective equipment is the portable testing equipment that we discuss now. This very interesting is portable, it's handy, right? And also provide a lot of, you know, confidence, right, to both utility and also the consumer. So in Thailand, as I mentioned to you, the purpose number one is about to handle customer complaint, right? Because some of them do not believe that, so they need to prove. So the second things, right? They use a portable equipment because they would like to detect the wrong wiring, right? Because when they do the installation at the beginning, they train different group of technicians, right? Some of them well training and then doing the correct wiring, but some of them, you know, they're not quite experienced enough, then they make the wrong wiring and then causing the safety issues. So this equipment could be used, right, to detect the wrong wiring. And another one, they would like to check the meter qualities on the sample basis, right? So they can do, not every meters, but some meter that could be used as a sample of the group. And also they would like to enhance the service level, right, of PEA. So the people have a very good confidence on that. You know, during the COVID situation, the government demanded people to work from home, right? So they use a lot of electricity. So, you know, the electricity bill goes up very drastically. So this is also one of the proof that we have the correct bill to them. And another is they want to solve the problems on site and immediately, right? Because if you take the meter back and do calibration or whatever investigation and come back to the site again, they might have some, you know, additional issue from the consumer and then take it back and forth. So it's not convenient enough. So by having the portable equipment, that solves all the case, right? And that is the instrument that they use.
Yeah. I can certainly relate to having high electricity bills, having been at home for the last 12 months. I can absolutely understand that.
Right.
Horst, you've been sitting there quietly since your presentation. Do you have anything to add to anything that has been mentioned so far, particularly around the sort of advantages of using the customer side?
No, I'm not quite. I'm listening very carefully because when I get input from real users, it's very important for us. So, I want to say something regarding William's comments. And you see, we as a supplier, we always must find a compromise. First of all, first requirement of such a portable is robustness. So they go on site in tropical areas, or maybe also very cold areas. In Saudi Arabia, for instance, sometimes you have a sandstorm and plus 50 degrees. Philippines, you have 100% humidity, and so on. So these are tough requirements, and the portable instrument still must work. So robustness is very important. True. Next thing, another requirement is weight. Such a portable instrument must have a low weight, otherwise it's not accepted by users, right? When I remember in the past, when I started, such an instrument has a weight of 60 kilograms or more. Nowadays, we talk about less than 10 kilograms with more functionalities. And the third one, of course, also an issue are the costs, the production costs. So we also must offer an instrument which is in a certain price range that you can accept it. So these are things which we always have to consider. And some of these robustness and weight, for instance, these are mutually contradictory. Is this? So we have to find a compromise for that. Regarding the requirement for ANSI meters, it's not so easy to get access to the meters. So we have there, for instance, also adapter to plug in. But of course, you have to disassemble the meter, put the adapter in, and plug the meter again. So these are always also issues, yes. So I listen very carefully what you say, and very interesting for me. Yeah.
Before I move on to our next question, I just want to remind our audience that again, this is a pre-recorded conversation, but we are able to field questions. We do have representatives in the audience today who can field questions through the chat box on the right-hand side. So if you do have anything you want to ask, please do take the time to type in your question, and we will respond to you if we're able to. Ken, I want to just come back to this smart meters topic we've touched on a little bit with you, and obviously TMB's rollout. Nowadays, smart meters provide a lot of anti-tampering functionalities. Why is it still necessary to execute on-site tests to detect intentional or accidental mistakes?
I think we have to think about the smart meter features and also the portable test sets as something that complements one another, right? On one end, when you have the smart meters, you have all the anti-tampering functionalities and all. But essentially, what it does is it sends the events, or rather, if there's tampering on site, it sends all these activities back to the control center, for example, in TNB, right? Mm-hmm. So what it does is it tells us, okay, somebody is opening the meter cover, for example, right? But all that it does in that sense is it tells you that something is happening, right? Now, when we get this kind of events, they may come in numbers that sometimes we do not expect, right? Depending on whether the tampering or rather the event happening is natural or unnatural. There's always the need for us to go and counter check on site, right? Mm-hmm. Why am I saying this, right? You just imagine in an area where you have a bunch of meters that suddenly reporting that the voltages is below the threshold or above a particular threshold, right? So when you have enough of these things happening, they all come back to a command center of sort. You will still need to go there. But what it does in that sense is that it provides us the insight without having to do too many repeated visits, right? You have it collectively together. You send a team that goes down, does the inspections together. And then, of course, with that, then you reconfirm whatever that the system is seeing. And this is it has proven very crucial for us here in TNB especially, because of on the with the introduction of smart meters, there's always the concern of cybersecurity breaches and all that, right? So when you have a visibility to your systems, it gives you that ability to detect this kind of intrusion. And then, of course, when you go on site, there's always the confirmation that we can see when we are there on site. It is actually sending messages to the customer, right? This is an electricity meter. You shouldn't be touching it. We know, right? We're not We're not. It shouldn't be construed as an invasion of privacy, but more so that what we want to do is to be able to manage the meters better, offer better services to the customer. And I think what's especially comforting when we are able to detect such cases imagine if you are someone who owns a particular building, right, or rather a particular unit, and your tenant is actually doing something illegal, right? The utility is now able to tell you, all right, trigger you ahead of time so that you don't end up having to pay for the wrongdoings of somebody else. So if you put the smart meter and the portable test set together, it forms a very strong and useful relationship, right, in delivering this kind of features to the customer. So if we're just going to solely depend on the smart meter telling us that without testing on site, I think we actually miss out on the value that we can actually derive looking at it as a partner, right? That gives you the end-to-end that you are looking at.
Yeah, makes complete sense. William, in many countries, portable testing is considered to be a useful part of a measure catalog to reduce non-technical losses. It's something you touched on again in your opening. Can you tell us a little bit about the results and experiences in Morocco with regards to this?
Well, for Meralco, I think the portable test equipment has provided substantial benefits towards the reduction of non-technical system loss. We usually test around 30,000 services in a year. And in Meralco, we categorize the irregularities in metering installations into two. First is the wiring related or the installation related. And the other one is the meter related defects itself, which means that the problem is within the meter. Installation related can be attributed sometimes to those who make committed errors during the installations, or sometimes due to wear and tear of the equipments, or maybe the meter also. And sometimes there's also the customer who tries to tamper with the wiring so that his bills will be reduced. Now, our portable test equipment can help detect these abnormalities in what we call a procedure mentioned earlier as the phase angle testing. We usually conduct that for the secondary and primary city-rated metering installations. Now, for the meter defects or related defects, we usually conduct accuracy testing for them when we see that the meter seals are intact. The seal that locks the cover from the base plate. When it is intact, then we conduct the accuracy testing of the meter on site. But when we see that this meter has been, the seals have been damaged or broken or missing, or sometimes we feel that's not the original seal, then we have a procedure called the meter for log test procedure. This is a procedure approved by our regulators, wherein the meter is replaced and the removed meter is brought to our laboratory for testing in the presence of a representative from our regulator. That way, we ensure that testing is fair and above board, so that the result can be what we call trusted by both parties. So this testing can confirm if the meter is intentionally or the irregularities in the meter was intentional, and so we can declare if the meter is tampered or not. Anyway, this on a yearly basis, we have around 50,000 effective or tampered meter, yeah, found during the testing in our laboratory.
Okay. And Chayod, I wanted to touch on something that Horst mentioned in his presentation. He spoke about ratios in terms of number of cases and losses. Can you generally sort of agree with what he was saying related to residential, commercial, and industrial metering?
Okay, so for PEA, based on the statistic that they collect so far, in 2020, PEA had around 100 violations of high voltage meters and 2,500 violations for low voltage meters. So concerning the high voltage cases, that result in approximately 3 million kilowatt hour losses, right? And the losses in low voltage metering is about 500,000 kilowatt hours. So you see it's a huge amount of energy that losses because of the tampering. So in general, we confirm and we totally agree with Horst, right, about that. And also the number of unreported cases might be likely high, right? And what we have to think about additionally is about the additional costs, right, for the damaged equipment, maintenance, labor costs, inspection team costs, and administration and legal effort that they need to take into account, right, when we do the try to overcome that tampering. So right, the equipment, right, the technology, for example, AMI together, right, they can help identifying that non-technical losses, and also give a very good confidence to both utility and the consumers, right, that meter perform very well and accurate enough.
Horst, I want to bring you in here as a supplier of portable testing equipment. What do you have to add to the conversation we're having around the tampering and non-technical losses?
Well, our portable instruments are generally prepared to detect tampering. Tampering, for instance, extension of the burden for CT, or short circuits or interruptions. This can be detected by our instruments. So it is a very important tool to reduce the non-technical losses. And we have also some figures from utilities with such a program that they really could reduce the percentages of non-technical losses.
Okay. Something I would be interested in asking any of you, we've touched on smart and digital, and I'd like to ask, is hacking non-physical disruption of your equipment something that you're facing increasingly?
Maybe I can share a little bit on TNB's experience. So I think the introduction of smart meters it actually brings a lot of interest on the topic of hacking, right? Rather than the conventional ways of going to 1 meter, now you can actually do it through a system, right? If you have access to the system. But I think fundamentally, what is most important, the threat of hacking will always be there. What we can do and what we are doing here in TNB is to have that hardening aspect where we make it tougher and tougher for hackers to come in. So some of the functionalities that we have implemented, we call the key management system, for example. Essentially, that means every meter has a specific key, right? So whatever you want to do, you need that unique key to access that meter. So in the event that hacking does happen, unless you have the keys to everything, you are only able to actually compromise a particular meter itself. So those are new things insofar as the AMI is concerned here, right? It does help us in the control of the hacking itself, but what I want to also add on to this subject is that the portable test sets that we are using right now, apart from that hacking risk that we are looking at, it has without a doubt, insofar as TNB is concerned, help us to actually show to the customer that whatever that is happening out there, we can see it. That's why I mentioned earlier, it's a partnership between the two, right? The AMI, the AMI, and also the test set itself. We go on site, we show, and customers are very, very excited to see this kind of gadget. You know, Horst mentioned earlier, it being robust and all that. It's able to show the consumption patterns and all those kind of things. It may be something that the people who are not technically inclined may not fully understand, but I think the displays, the pictures that we show when we are on site, it helps to give that assurance. And at the same time, it tells the customer, yeah, hacking is a threat, but there is a way to go about it. And this is one of those ways that we are doing over here in Malaysia.
Sure,
right?
Sure. Chayod, William, anything to add to that from a sort of a new threat?
Right, so I have something to share with you. We got some detection of the magnetic interference, right? That I remember during the installation of these AMI meters, there are some cases that use very strong magnetic to interfere with the meters. But at the end, they found that electronic meter that we use, smart meter, it means it's very reliable, and they can resist to that level of magnetic interference. So they don't do that anymore, right? But we found very few cases. And a very common cases in Thailand is the reverse connection at the input to the meters. I mean, they swap between line neutral connections, because some of them might have known that the neutral current sensor is not common for all meters, right? Some meter got, but some meter don't have that. So they try to do tampering in that case. So this is another point that we need to improve the specification to have both current sensor on phase and neutral, so we can do the detection on like the wrong phase, right? The swap of the connections. And we found one case about tampering, but it's not in the field, because in the field, every time the technician go there, they need to get the key, like Ken mentioned, and the key has an end dating, right? So they can expire within like 5 or 6 hours or a day. So they cannot use the same key at all. So, but the case that we found is about the back office. So they try to put a Trojan or some, what they call the, you know, they try to spoil your data and asking about the money, right, to decrypt that data, right? So yeah, this is one of the things. So we improve the system by using two what they call double factor authentication, right? You think about OTP, right? First time you get in, and then they need to have the OTP to confirm again. So that help a lot, right, to solve that problems. So you know, it's very scared at the moment, and you know, the hacker try to threat not by US dollars or Thai baht, but they're asking for the Bitcoin, right? For the Bitcoin. If we pay for the Bitcoin, let's say I mentioned about 2 Bitcoin, then I will decrypt your data. It's something like that. But fortunately, we have the backup data, so they have no issue. But then we found that it's increasing more and more threat about these security issues.
Yeah. 2 Bitcoin is increasing in value almost daily at the moment, it seems. So yeah. And William, anything from your side, from a Meralco perspective, on that kind of digital hacking side of things? Is it something you've experienced?
Well, as far as the digital hacking, I think it's not yet that much here in Meralco, because we have yet to fully implement an AMI metering. We're just planning for it. We do have some thousands meters, but it's only for the prepaid electricity meters. But again, as mentioned earlier, these tamperers usually concentrate on just two things. It's just they tampered with the installations, or they tampered with the meter. And most of the time, we can see that there are tamperings within the meter when we ask them for, when we subject them to laboratory tests, as mentioned earlier. So resistors and other foreign objects found inside the meter, just to reduce the registration.
Sure.
All sorts of things like that.
Sure. So this is something you have to look forward to as you roll out your smart meters then.
Yes, we will.
Horst, bringing you in again from a supplier's perspective, I suppose a few years ago, this would have been a future challenge, the hacking side of things. What do you see as future challenges for your sector then?
Well, in general, we have to follow the metering industry. You see that the technology of the meters is changing. The meters become smarter and smarter. Nowadays, we also talk about smarter CTs and BTs, non-conventional instrument transformers with sampled data values and these things. So we have to follow the technologies which are implemented in general. And also other new fields are now, for instance, e-mobility is a big issue nowadays. We just launched the first adapter for testing AC consumption of a car, of electrical vehicle. And also we now produce also test benches for DC meters. So DC metering is also now a topic. In general, we have to listen very careful and must find then, and also other things are new technologies which are available, electronic technologies where we also can use, for instance, nowadays a touchscreen or wireless LAN or Bluetooth. These are technologies which are available, which we also want to implement where it makes sense. That's very important. It must make sense. It must be in a certain price and cost range as well. That's very important.
Sure, sure. Yeah, the mobility side is something that we're seeing increasingly globally, obviously, but a lot of interest in e-mobility here in Southeast Asia. We're rapidly running out of time, gentlemen. I do have a question that I want to ask everyone, but perhaps we can kind of wrap it into any closing remarks that you might have. We'll go around from my left, so we'll start with Ken, as we seem to be doing. I'd like to ask each of you just some insights into when designing the requirements for a portable meter, a portable test set for your utility. What functions or what digital technologies should be included in order to maximize the ROI? What do you think is what do you look for? What would you advise others to consider? And perhaps when you compare your needs and what that wish list looks like, what's missing? What important functions do you feel that at the moment need to be incorporated? And then obviously we can provide Horst a chance to respond to that. So if I can ask Ken first, what do you look for? What would you advise, and perhaps what's missing in the market at the moment?
Yeah, I think in so far as TNB is concerned, and looking at the responses we're having from the customers right now, and also the regulator, actually, very much the regulator, right? So when we do this inspection, as Horst rightfully mentioned it, you need something that is robust, right? But there again, we're talking about high precision equipment. right? With the day-to-day site conditions and all. So what is essentially important right now is when after we've done the testing and all that, the ability to be able to provide some form of a record, or rather, it's like when you go for a blood test, right? Test results, right? The ability for us to provide that to the customer, I think that would be something very useful, which TNB will be looking for, because the testing has concluded, right? We've done the testing and all. Now, that paper, whether it's digitally sent or whether it's actually a printout and so on, that would be the certification of the bill of health, right? Of the meter. That really will actually assist in the rollout of EMI in ENB. Okay, I would deem that as the main priority in so far as this is concerned, because we've done all the tests and all that. So that formalization, it really gives the stamp of approval, actually.
Yeah.
Right.
Makes sense. Makes sense. William, you're the next on my trip around my screen. What again to you? What do you look for? What would you advise people look for, and perhaps what's missing?
Well, I do agree with what Ken said earlier about the form or something that will show the result of the test and be provided to the customer as acceptable report that can be presented or shown as a proof that the meter is accurate or been tested. And also, aside from what Mr. Horst said earlier, that the test equipment should stand the conditions in the field, and also it should be also good enough or adaptable enough to the different forms of the meter present in the market, so that we can only bring one instrument or one test equipment that will cater to all the types of meters, and also we can say that this is a dual portable test equipment. Perhaps that's one of the things that we are looking forward to.
Yep. And Child, same to you.
Yep. So I think differently a little bit, because now we are going to the IoT era. So we play around with the cloud systems, we play around with the big data analytics, right? So we have seen many devices now upgraded to be IoT-like device that could be connected to the cloud, that can use the online data to do analysis, right, and give the feedback to the consumer or utilities. So what I would like to feedback to Horst, for example, number one, if you think about including IoT technology to your portable equipment, that would be very interesting, right? And number two, concerning the COVID-19 pandemic, for example, in Thailand now, we are demanding to stay at home from home, so it's no way to go out and working in the field test. So is there any solution or any way that we can, we can design the portable equipment and sending that right to the consumer or to the branch office, so they take very short time, but we can collect the data and use the online data for analysis. So that could be helpful, right, in the situation of COVID-19 like today. Right. What would come to my mind? Yeah. Thank you.
And Horst, I could see you taking notes there. As a supplier of portable test equipment, what do you think about these requirements coming from your clients as such, and indeed the sort of the further demands of the market? How does MTE work to fill these perceived gaps that as we mentioned?
Well, these are exactly the challenges which we have. The robustness and withstanding conditions on site it's one issue. It's always an issue for us. So when we, for instance, when we use a IP65 transportation case, it's another 4 or 5 kilogram weight for our instruments. So for instance, this is that. And big topic is this communication with the instrument. Our instruments nowadays are equipped already with some wireless LAN. So generally the technology is available that the service center can communicate with the portable instrument on site, generally. At the moment, there are still some security concerns. You see, when you go on site and you control it from your office, there's always a question, what are you doing? Because you are not on site. So the security is very important there. And this is one of the reasons we hesitate a bit to remote control instruments from an office. But IoT will be a topic as well, and we listen very careful. And yeah, so let's see what will happen in the future.
See what the future holds. Before I wrap up, gentlemen, has anybody got anything they would like to share? Any last closing thoughts, any last closing comments before I close this off? Speak now or forever hold your peace? No? Okay, in that case, it just leaves me to thank you all very, very much for taking the time to join us. We're really grateful for your thoughts and insights today and sharing those with our ENLIT Asia network. Thank you very much also on behalf of MTE, and also thanks to MTE for hosting this discussion. Horst, thank you very much for joining us. And lastly, thanks to our audience today. Thank you very much for taking the time to join us. I do hope you took the opportunity to engage with our speakers, to ask any questions that you may have. And by all means, please do take the opportunity to reach out to our speakers through the tab at the top. There's a tab at the top of your screen that says speakers. You can contact these guys directly with any questions you may have or any follow-ups. Gentlemen, it's been an absolute pleasure to spend some time with you this afternoon. Thank you very much.
Thank you.
Thank you very much.
Thank you very much.
Bye.
Thank you. Bye-bye.